those are the questions that we are going to focus on today. Okay. All right, so we can start. Okay, so our first question there is on binary operations. Okay, so on binary operations. And then what are they saying in this question? Okay. Okay, so they are saying given the operation star, okay, given the operation star there, and the operation crossed circle there, okay, on a set of all real numbers is defined as A star B is just equals to the modulus of A minus B, and then A second plus B is equals to A. Okay, for all values of A and B that are member of real numbers. Okay, so the first question there is saying prove that star is commutative. Okay, prove that star is commutative. And we all know that when you're proving something, for it to be commutative, we said that A star B there, okay, should be equals to B star A. Okay, A star B equals to B star A. That's the rule of commutativity. Okay, so let me go to my board. It simply means that we have A, okay, we have A star B there, which is equals to, okay, which is equals to A minus B in bracket, in modulus A minus B. Then I have my modulus there, okay. Then here the rule states that A star B should be equals to my B star A. Okay, so we are going to replace this with that, okay, because A star B is equals to that. So on this side, we are just going to have A minus B in modulus, okay. Then the other side, we are doing B star A, okay. So B star A, we are going to follow the same rule there, meaning wherever there's A there, we put B, and wherever there's B, we put what? A, okay. So meaning we are going to have B minus A modulus, okay. Then from there, you can test what value you're going to find on your left and what value you're going to find on your right, okay. So you can say, let my A be my 1, and then let my B be 2, okay. So you test this into this formulas. So here it's going to be 1 minus 2 modulus is equals to, then the other side you have 2 minus 1 modulus. Okay, so what is 1 minus 2? You're just going to get a minus 1, okay, in modulus. Then on the other side, you're going to get a 1 in modulus, okay. So we know that whatever is in between two moduluses, okay, becomes a positive. So meaning this negative 1 here is just the same as 1. Even that 1 there is just the same as 1, okay. So we can see that the right side is equal to the left side, okay. Then you say, hence, my star there is indeed, okay, commutative. So make sure you write in capital letters there, commutative. You can finish the word there. Okay? So that's how you prove the first one, okay. Then here they're saying prove that the crossed circle there, this symbol here, a circle and a cross inside, is associative, okay. So what rule governs associativity? Okay, so for associativity, we have to introduce a third member to this formula there, okay, meaning that, A opens crossed circle there, B, okay, in brackets, then doing it with another crossed circle there, okay. Then I introduce. Hello, you're saying something?
Yes, what does the cross circle mean?
It's just a symbol. It's just a symbol. Doesn't mean anything. It's just a symbol. Like just like this star there. It's just a symbol. So this symbol here, you have a cross inside and the circle. Okay, that's why I'm saying a crossed circle. Okay, so associativity, it means that if I have A and B in my brackets being operated on C, then it should be the same answer as A, okay, crossed circle there. Then in the brackets, I have my B and C there. Okay, so I have this. So if what I have on this side is the same as what I have on that side, then we say that this symbol there is indeed what? Associative. Okay, so first we have to know the rule that is governing it. You can see there that A crossed circle B is just A. Okay, so the answer you get the first element that is there. Okay, so A crossed circle B is just A. Okay, so let me go back to my board and then I say A. Okay, and I have my crossed circle there. Okay, cross per circle B is just equals to A. Okay, then what is the rule for associativity? We said A, okay, B in brackets, and C there should be equals to A, okay, cross circle there. Then you have your B and C in the brackets. Okay, so you have something like that. Then we can solve this actually. Okay, so whatever is in these brackets, okay, A, this symbol B is just equals to A, meaning here I'm just going to get A, okay, then star C, okay, then is equals to here I bring down my A with the circle there. I don't know why I wrote a star. I'm using the star. Okay, then here we have B cross circle C. Okay, so B cross circle C, according to this, we just get the first one there. So we are going to get B there. Okay, so we are going to get B there. And then here, A cross circle C, we're still going to get A, which is the first one there, is equals to, even there, A cross circle B, we're still going to get A. Okay, so you can see that the left-hand side is actually equals to the right-hand side. Okay, meaning indeed this symbol there is associative. So make sure you write it in capital letters. Okay, you can finish the word there. It's associative. That's how you go about that question. Okay, let's move to the next one. What is it saying? It's saying show that okay, it's saying A star B as this cross circle C is equals to that. Okay, so we are going to show that using the rules that we've been given there. Okay, we are going to show that using the rules that we've been given there. Okay, just simply apply the rules and you'll be able to get your answer. Okay, someone has turned on their camera. Okay, so meaning on this one here, on number 3 there, okay, this one there, okay, we're just going to solve it as they are giving it to us. Okay, so here I will always start with whatever is in the brackets. Okay, okay, so there we have A star B cross circle C. Okay, so from this, okay, we have A star, okay, then the rule that governs a combination of two elements with this symbol is given here. Okay, so if I have two elements there, I'll just get the first one. Okay, so B cross circle C is just B. Okay, because B is the first one. So on your left there, I have A star, the result of this, which is just B. Where am I writing a D? Okay, which is just B there. Okay, is equals to. Then I look at the other side. Okay, I have in the brackets there, I have the operation star there, even there star. Okay, meaning I want to find the answer of that. I'm also going to find the answer of that. Then I apply this cross circle there. So what function governs the star? Okay, so the star is governed by that. Okay, so A minus B there, I'll just write that I have A minus B there, like that. Okay. Then I'll say cross circle here on in between. Okay. Then they have A star C following the same one there. Okay. It means the A is in the place of A, but the C now is in the place of the B there. Okay. So meaning their side, I have A minus C. Okay. So this is what I have now. Okay. Then this side, what will I have? Okay. What will I have this side? A star B is governed that it is just A minus B in modulus is equals to, okay. Then here I have these two expressions, okay. One in modulus and one in modulus being operated by this cross circle, okay. So we said the cross circle, if you have an element there, cross circle element there, you just get the first element there, okay. So this is the first group, that is the second group, okay. As long as you have a cross circle there, you just get the first group, okay. So you can see that it's just A minus B there. I don't know why I'm writing a plus. Okay, it's just A minus B there. Then now you can compare what you have on your right here and then what you have on your left, okay. You can see that it's actually the same thing, okay. So we have proved as simple as that, okay. Nothing difficult about it. One day they even gave us, they even gave it 2 marks because it's just applying whatever rule they have given us here into this equation there, okay. Then the other one is evaluate now, okay. Evaluate, they are saying -3 star, then we have that in the brackets, okay, meaning we have a -3 there, star, okay. What do we get when we evaluate what is in the brackets, okay? First number, second number, we just get the first number, meaning this one will just be 1 there, okay. This one cross circle 4 will just give us 1 because that's what the rule says there. Then from there, we can apply the star operation now, okay. So the star operation, we know that this is going to be equals to modulus of -3 minus 1, okay. So modulus of what is -3 minus 1? It's just -4, okay. Then from there, you will see that your answer is just 4. Okay, so we are done with this question. Any question on this part before I move to the next question? Okay, no question. I'll move on to the next.
Sir, I have a question.
Okay, yeah.
I wanted to know how did you know that they only wanted A as the number one that's in front and the whole and not the whole operation only standing for A?
Come again with your question. I didn't understand.
On the one with the circle, the cross circle.
Yeah.
Yes. How did you know that A meant the first letter and not what the whole operation means? Because I got confused when you said you did that. So then A does not stand for the whole thing?
The whole thing like this one here.
Yes.
No. This rule is simply saying that whenever you have 2 numbers there, okay? Whenever you have 2 numbers there being operated by this symbol, you always get the first number there as your answer. So you can see A cross circle B, you just get A, which is the first number in this case, okay? So that's what the rule is giving us there.
Thank you, sir.
Okay. You're welcome. Okay. So I'll move. I don't know what topic is this now. Okay, so they're saying solve the logarithmic function of that equation there that we've been given. Okay, so we are solving that equation. Logs. Okay, so that's a very actually very simple question. Okay, because you only have to know some properties of logs, then you apply them. Okay, so let's go to my board, then we can solve it from there. Okay. Okay, so what do we have in the question? Okay, in the question they're saying solve for x in the logarithmic function that. Okay, so how do we solve that? So you write your equation there. I have my log, then I have my x to the power 8 there. Okay, is equals to log x. Okay, then this log x is in brackets, then to the power 4. Okay, so how do you solve such a question? Okay, so for you to solve such a question, you have to use the let method. Okay, you let any data of your choice be equals to log x. Okay, so on this guy here, we know there's a property that says that if I have a power here, this power can drop down and it can come in front like that. So meaning on this side, what do I have? Okay, on that side, what do I have? I have 8 log x. Okay, I have 8 okay log x on that side. I've dropped this power from where it was there. I've dropped it. Then on the other side, you still have your log x to the power 4. Okay, then now you say let, okay, you say let my p, okay, you can choose any data there, be equals to log x there. Okay, so it means that wherever there's log x in this function, I'm going to replace it with p. So meaning I have 8p there, which will be equals to there I have p to the power 4. Okay, so I can put these guys on the same side, meaning I have a p to the power 4 minus 8p there is equals to 0. Okay, then after that, I can factorize and then find my p. So p is common there. What do I remain with? I remain with p to the power 3 minus 8. Okay, so is equals to 0. What do I have from this? I have p is equals to 0. Then the other one will definitely be p to the power 3 is equals to what? 8. Okay, so here you can find the cube root. Even there you can find the cube root there. Okay, so what is the cube root of 8? Okay, so to the power 3 and the cube root, they cancel, meaning I have only p here is equals to, what is the cube root of 8? It's just 2. Okay, so we have 2 values for p there. Then let's now find our x. So remember we said that p was equals to log x. Okay, so our log x has come back. So meaning we're going to equate this log x, first of all, to 0, and then this log x to 2. Then we find the x values there. Yeah, we find the x values there. Okay, so meaning I'm going to have my log x is equals to 0 on this side. Then on the other side, I have log x being equals to 2 there. Okay. So from there, how do I solve it? Okay, we know that any log that is written without a base, it simply means it has a log 10. Okay, if it is written without a base, then it has a log 10. Meaning there, okay, I have my log 10. Even there, I have my log 10. Okay, so how do I find the x? I change these logarithmic functions to exponential functions. Okay, and what do I use to convert that? Okay, we said we always use this mnemonic known as BAM. Okay, base to the power answer is equals to what is in the middle. Okay, so the 10 is the base, the answer is the 0, and what is in the middle is the x. Okay, so base to the power answer is actually equals to what is in the middle. Then even there we do the same. Base to the power answer is equals to what is in the middle. Okay, so what is 10 to the power 0? We know that any number to the power 0 is 1. And then this side, we're going to have x is equals to 100. Okay, so your x there can either be 1 or it can either be 100 there. Okay, so these are your x values there. So that's how you solve that question, the first question there. Okay, then let's solve this inequality there. Okay, let's solve that inequality there. Okay, so even in that question, we are going to use the let method somewhere. Okay, so we are going to use the let method in that question again. Okay, so going back to my board, let's go into it. Okay, I had e to the power x minus 2 in brackets. Then the other one was e to the power x. Okay, e to the power x minus 3. Then they were saying this should be less than 2x to the power, e to the power x, like that. Okay. So how do we solve that? Okay, how do we solve that? We first of all expand. Okay, we first of all expand this expression. Okay, then we bring all the elements on your left side, so that on your right of the inequality, there's just a 0 there. Okay, so what is e to the power x multiplied by e to the power x? It will just simply be e, okay, to the power 2x. Okay. Okay, then what is e to the power x multiplied by minus 3? It will just be 3e to the power x. Okay, then what is minus 2 there multiplied by e to the power x is just minus 2e to the power x. Okay, then minus 2 there multiplied by minus 3 will just be a plus 6. Okay, then we said we bring all the terms to the left side. Okay, so meaning this one will move to that side and it will become a minus 2e to the power x. Okay, and this should be less than 0. Okay, be less than 0. Then there you can put the like terms together and simplify the equation. Okay, so this one there, okay, this one here, it can also be written as e to the power x. Okay, then this e to the power x is raised to power 2. Okay, so 2 multiplied by e can still give you that. Okay, so we can write it in that way. Then we say we have a minus 3e power x minus 2e power x and then minus 2e power x, meaning there we have 7 e's power x. Okay, then we have a plus 6. Okay, then I have less than 0 there. Okay, so from here now, what am I going to do? Okay, what am I going to do to find my answer? I'm going to use now the let method. Okay, so wherever there's e to the power x, I'm going to replace with p. Okay, so e to the power x there is just equals to p. So meaning I have p squared there minus 7p, okay, plus 6. Okay, then here instead of writing this inequality symbol, okay, so for the sake of solving, I'm just going to write is equals to, okay, but at the end, when I find my answer, I'm going to come back for this. Okay, so I have that equation there. Then what are the factors here? Okay, the factors are just minus 6 and minus 1, meaning when we factorize this, we're just going to get p minus 6. Okay, then on the other side, you have p minus 1. Okay, is equals to 0. So let's find let's find our p. Okay, let's find our p. So our p will be equals to, okay, if I equate this to 0, it means my p will just be 6. Okay, if I equate this to 0, just my p will be equals to what? 1. Okay, so that's my answer there. Okay, then I'm going to bring back the e to the power x there. Okay, is equals to 6. Even that side, I'm going to say e power x there is equals to 1. Okay, so how do you solve such an equation? You introduce ln there, even there you introduce ln, there you introduce ln, even there you introduce ln. Okay, So if I introduce a, then it means this x is going to drop there, okay, because this will be in a logarithmic form. So I have my x ln e, okay. Then on the other side, I have a ln 6. Then this side, still the x is gonna drop. Then you have x ln e, x ln e there is equals to ln 1. Okay, so let's find the x. So ln e, okay, ln e, when you punch it on your calculator, you're just going to discover that that's the 1. Okay, ln e is just a 1. Okay, so meaning here the x is just what? The x is just equals to ln 6. Okay, that's the answer there. Then here, what is the x? Okay, what is the x there? It means there the x is just this ln e is 1. Okay, what is ln 1? Okay, ln 1 is equals to 0. Okay, ln 1 is equals to 0. You can confirm that on your calculator, meaning my x in this case will just be equals to what? To 0. Okay, so these are the values of x that are found. Okay, but remember in the equation here, we didn't have an equal sign. We had an inequality there. Okay, so I don't know if it's here or it's where, but I said whenever you have an inequality there, okay, which is less than, it means your answer, your final answer should be represented in this form. Okay, you write your x there, then you write 2 less than signs. Okay, then you put the bigger number that you found here. Okay, bigger number, then the smaller number, you put it here. I don't know if I was explaining this concept here or where, I don't know. Yeah, so meaning on those numbers that we found here for x, where are they? Okay, on this number that we found for x, okay, since it's an inequality equation, we're going to say my x, okay, is less than, and my x again there, you put the less than symbol, then you put the greater number there, and then the smaller number. Okay, so which one is greater, ln 6 or 0? Though, which one is greater, ln 6 or 0? Okay, so ln 6 is giving us 1.8. Okay, meaning ln 6 is bigger. So you're going to put your ln 6 there, okay, then your 0 there. So this there is your answer, okay, to that question that we are answering. Okay. So if you have any question, you can ask. Okay, we move on to this. I feel this one is very simple. So find the domain of this where f is equals to that and g is equals to that. Okay, so here we are finding the domain of a composite function. Okay, we're finding the domain of a composite function. So it's very important to note that in the composite function, we have two functions. Okay, one, we have the output function, and then we have the input function. Okay, so here they have given us f of g, meaning that we should insert this g into the function f. Okay, we insert this g into the function f. Okay, so meaning which one is our input function and which one is our output function. Okay, so since we're inserting g into f, okay, it means our g there is our input function, and then f is our output function. Okay, so when you're finding the domain of a composite function, always, okay, always make sure that you also know the domain for the input function. Okay, so we first have to find the domain of this guy here. Okay, first have to find the domain of that guy, which is the input function in this case. Okay, the input function, and then this guy there is the output. Okay, it's the output function. That's where we are inserting our function. Okay, so how do you find the domain of such a function? We can tell that this function here is simply a radical function because I can see the square root there. Okay, meaning that the x values that should be here, okay, should always be or not necessarily the x values, I'm saying the value that should be under the root there should always give you a root, okay? And which numbers gives you a root? It's always the numbers 0 and the positives, okay? 0 and the positive numbers. You can never have a negative number. Okay? So to find the domain of G, okay, to find the domain of G, we're going to say the number under the root there, okay? The number under the root there should always be equal or greater than 0, okay? Then we solve for 4, okay? I solve for x, I mean, okay? So x there is greater than or equal to -4, okay? So this here is the domain, okay, for this input function, okay? It means that whatever x that we are going to put there, okay, whatever x that we are going to put there, it should be either -4 or greater than -4 for us to get a valid answer there, okay? So you can write this in interval form. It means you are starting from -4 there with a curved brackets because we are including it all the way up to positive infinity, okay? So this there is our domain for the input function, okay? So we find our domain and then we keep it just there. Then now we go back and then we find the actual composite function, meaning we input this G into this function there. What are we going to get, okay? So I'll come to my board there, okay? Okay, so meaning what function did I have there? Okay, add my f, okay, is equals to add 1 over x minus 2. Okay, that was my function. Then what was my g? Okay, my g there was g of x is equals to we had the square root of x plus 4 there. Okay, then now we are finding f of g. Okay, so f of g, that's what we are finding there. Okay, so is equals to, so you always first write the input function there, okay, which is 1 divided by x minus 2, okay, is equals to, then now you input this g into this, okay? So 1 is divided by this x there will be substituted by the function g, okay, meaning I have there plus 4, okay, then outside there I have my minus 2. Okay, so from here now, we can simply write it in this way, okay? You can say 1 over the root of x plus 4, okay? X plus 4, then you say minus 2, okay? So this here is our composite function, okay? So now how do we find its domain, okay? How do we find its domain? Okay, so the domain, we can see that this is a rational function because we have something over something, okay, in the form of those a over b's, okay? So meaning my domain there, how do we find the domain of a rational function? You simply equate the denominator to 0, okay, and you solve for x. And that value of x that you're going to get is what you're going to exclude from the domain, okay? So we are going to say root of x plus 4, okay, minus 2 is equals to 0, okay? Meaning what do I have? I have my root of x plus 4 there be equals to 2, okay? So from here now, we can square this side. Even that side, we can square it, okay? So meaning square root there, it means the square root will go. I'll just have x plus 4 there is equals to, what do I have this side? I have 4, okay? So x there will simply be 4 minus 4, okay? So x there should simply be never be equals to 0, okay? So for the domain of the composite function, you state that the domain of the composite function is that, okay, x is a real number, okay? X is a real number, but x should never be equals to 0, okay? So this here is the domain of the composite function, okay? Because when x is 0, what will happen to the function, okay? So if x is 0, if I put 0 there where there's x, it means under the root there, I'll only have a 4, okay? What is the square root of 4? The square root of 4 is 2, okay? Meaning on this part here, I have 2 minus 2. 2 minus 2 is equals to 0. And you can't have a 0 in the denominator, meaning this function will become invalid, okay? So there we found the domain of the composite function. Then what was the domain of the input function? Okay. So the domain of the input function, we simply found it was minus 4 all the way up to positive infinity like that. Okay, so to find now the final domain of that composite function, we have to intersect it with the domain for the input function. Okay, so for the domain of the composite function, okay, we can write it on the number line as this. Okay, okay, so there I can have my 0. And then here I have positive infinity. Okay, then there I have my minus infinity like that. Okay, so the domain of this input function, okay, is saying starting from minus 4 all the way to positive infinity. Okay, so I can put a minus 4 there, and then I shade this, okay, meaning I'm going to start there, shading it because it's part of it, then all the way up to positive infinity there, okay? This there is the domain for the input function. Then what's the domain for the composite function? We are saying all values of x except x is equals to 0. So how do you show that on this number line? You just put an open circle on 0. Then here you show arrows going like that, okay? And then even that side, you show arrows going like that, okay? So where do these two lines overlap? Or where one line is on top of the other, okay? So we can see that it starts here, there. Let me change the color. Okay, we can see that it starts from here, okay? It's overlapping, overlapping, overlapping. Then on 0, the 0 is there in the line below, but it's not there in the line above. Okay, so we jump the 0, and then we continue again, shading like that, okay? So meaning the intersection there starts from minus 4 all the way up to 0 without including the 0. Then again, it starts on the 0 without including it, all the way to positive infinity. Okay, so the domain there will be equals to, okay, minus 4 all the way to 0. Okay, then I say union, starting at 0 again, all the way to positive infinity. Okay, so what types of brackets do I have to put? Here I put curved because the 0 is not included. Even there it's curved. Okay, then there the minus 4 is included. Then there I put a 0. So this one here, guys, is our domain for the composite function. Okay. If you have any questions, feel free to ask. Okay. All right. So we've done that question. We can move to the next one. What is this question saying? Okay. They're saying on the same axis, sketch the graphs of f of x and h of x. Okay. So the first graph there is very simple to graph, okay? Because that's just a linear function in modulus, okay? So how do we graph a linear function? We simply come up with a plot, okay? A table of x and y's, okay? So a table of x and y's for this function, okay? We can say that that is my x there, and then this is my y, okay? So make sure you pick numbers covering from the negative side all the way up to the positive side, okay? So even 3 are enough for a linear equation. It's not hard to graph, okay? So you can just say I have minus 1, I have 0, and I have 1, okay? So input these, okay? Input these x values into the equation, and see what it will give us. Okay, so meaning here if it's just y, okay, so this y, guys, represents f of x. Okay, so if this is just y, then down here I have modulus of y. Okay, so let's input. Okay, so -1 into that equation there inside. Okay, so it means 3 multiplied by -1, which will just give me what? It will give me a -3. Okay, to give me a -3. Then that -3 plus 1, it will give me a -2. Okay, so this -2, if I apply modulus, then it's just going to be 2. Okay, then if I apply 0 there, it means I only have 1 inside there. Even the modulus will have 1. If I apply 1 there, okay, if I apply 1 there, it means to be 3 multiplied by 1, okay, plus 1, which will be 4. 4 there, okay. The modulus of +4 will still be 4. Okay, then now you go on your graph and then you plot these points. Okay, you plot these points. Okay, so let me go here now. Okay, so I will say my y, okay, and then my x there. Okay, so on the x-axis, what did I have? I had a -1, I had a 0, and I had a 1. Okay, then what did we find? Okay, we found that we had the -2 somewhere there. Okay, blah, 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 whatever we found there. So here I can say I have 1, I have 2, I have 3, then I have 4. Okay, I can even put 5 there. This is the y-axis. Okay, then this side, this is just the x. Then down there, I'll replicate what I have on top. So -1, -2, -3, -4, okay, then -5. So let's plot these points. Okay, so the first point there is -1 pointed to -2 or +2. Okay, so -1 pointed to +2. Okay, so the line, the point will be there. Okay, there. Okay, then this again is pointed to what was there? It's pointed to -2. Okay, so also write a star there for -2. Okay, then for 0, what did we get? We got 1, 1. Okay, so there's no negative part for the 0. So meaning I have 0, 1 there. Okay, then what's there? Okay, 0, 1. Okay, so meaning my x is 0, and then my my y is 1. Okay, then the other one, what did I have? I have 2. I mean, I have 1 plotting to the 4 there. Okay, so where is this? I have 1 being plotted to -4 there. Okay, where is -4? Okay, this is -4 there. So I have 1 being plotted to -4. So I can put a dot there. And then again, this one is being plotted to 1 -4 there. Okay, so you can see that, okay, you can see that this function, okay, this function starts, oh, I don't have a negative for the 4. Guys, you're not following. I don't have a negative for the 4. I only have a positive there. Okay, so you can see that for this graph, okay, without the modulus, okay, without the modulus, these are our images here, -2, 1, and 4, okay, without the modulus. So meaning without the modulus there, the graph would be like this, okay? Let me draw it in blue. So the graph would be like this without the modulus. It would pass there, okay, like that, okay? So this would be my graph without the modulus, meaning here y would be equals to 3x, okay, plus 1 there. Okay, 3x plus 1 without the modulus. Okay, but here we are plotting the 1 with the modulus. Okay, we are plotting the 1 with the modulus, meaning that what? Meaning that we are going to remove anything that is in the negative region. Okay, so immediately this graph here is crossing this line. We are going to remove whatever we have here down. Okay, so what do you do there? You dot it. Okay, So it means this graph here is going to be dotted like that, okay? Because it's in the negative region, okay, all the way up to here. Then when it reaches here, okay, it's going to be reflected in the x-axis like that, okay? Going to be reflected in the x-axis because we don't want this negative part, okay? So this graph now that is reflected is the graph of y is equals to 3x, okay, plus y with the modulus, okay? We've removed this negative part. You can even not draw it if you want. You can rub it, this one, okay? So meaning your graph will just be like that, and then like that, okay? So that's how you graph a linear function that has modulus, okay? So this is just one of them. We still have to graph the other one, okay? But this method here, the one that I use for writing the table of values, my screen has gone. Okay. Now, what can you see on my screen? Can you see the question or the solutions?
The solutions.
Okay.
So where it bounces there, is that a specific point that we also have to find, or is that just random?
Yes, that's where I'm going. That's where I'm going to. Just a minute. Okay. So this is what you're seeing here. Okay. So this point where it bounces off from. Okay. So for this question, you can plot it in two different ways. Okay. One way is just finding the point where it is bouncing, okay, and drawing the curve, as simple as that. Then another way is the one that we've used, where you have to plot first the points, then you connect them, okay. So this point here where it is bouncing off from, it is specific. And how do you find it? Okay, you simply equate whatever you have in your modulus, okay, whatever you have in your modulus, you equate it to 0 and so for x, meaning 3x there plus 1 is equals to 0, okay. So if you solve for x there, you are going to realize that it's going to be minus 1 over 3, okay. So this specific point here is where it's bouncing off, okay. It's just that this graph is not accurate, okay. But you can see that this number here is between 0 and 1, right? I mean, it's between -1 and 0, okay. So you can see that's where this point here, that's where the curve is bouncing off like that, okay. So in another way, when you want to plot this graph, okay, you just find the point where it is bouncing off there, okay, then you draw a V on that point. That's all. So you find it's bouncing on this point, then you just say V this side, V that side. That's all, okay. So that's the same approach that we are going to use to plot this equation on the other question. Okay, where is the question? Okay. Okay, so that's the concept we are going to use to plot this other one there. Okay, so note what is our x coordinate there. Our x coordinate there will just be, we equate whatever is in the brackets there, okay, 2 minus x is equals to 0, okay, meaning my x there is just equals to 2, okay. But in this equation, we have a -1 outside, okay. So it means that -1 is the point for the y, okay. This -1 there that is outside is the point for the y that is bouncing off, okay. So you combine the value of x there with the value of y there, okay. So meaning this graph will just bounce at 2, -1, okay, because we have a -1 there. In this one, we had we can say here we had +0, okay, meaning our graph was bouncing at -1, 3, okay, 0 there, because we had 0 there. But there you have a -1, so the bouncing point now is 2, -1, okay. So that's what we are going to do there, okay. So our bouncing point there is just 2, my 2 comma minus 1. Okay, so meaning I can put a 2 there. Okay, then my minus 1, where is it? I can see it's there. Okay, so on the this guy here, okay, I'm going to write my point there. Okay, so this is my 2 minus 1. Okay, then on this point you just draw a V. Okay, just draw a V that is facing upward, so meaning to go like that, and then the other one to go like that. That's all. You've drawn the graph of this guy here. Okay, if you don't want to use this method, you can still use redefining. Okay, but redefining takes time, so it's better you solve some of these questions with some tricks. Okay, yeah. Okay, so that's that on that question. Okay, so let me move to the next one. Okay, so the next one, what does it say? Okay, okay. I'm not sure if I'm able to see this question. Okay, so they're saying solve the equation log 9 x minus 5 plus log 9 x plus 3 is equals to 1. Okay, so that's the question that we are solving there. Okay, so how do you solve this equation? Okay, so x minus 5, x plus 3 is equals to 1. Okay, so let me go to my board. Then I would say, okay, so I have log 9 x minus 5. Okay, then they're saying plus. Okay, they're saying plus. On this side I have log 9. Then I have x plus 3. Okay, then it's equals to 1. Okay, so here we just use the laws of logarithm. So when you're adding something with the same base, it simply means you're multiplying whatever is here and there. Okay, so writing it as one thing there, it will be log 9. Okay, then I'm multiplying x minus 5 with x plus 3. Okay, is equals to 1. Is equals to 1 there. Okay, so here you can multiply. It means you have log 9. What is x multiplied by x? It's just x squared. Okay, x multiplied by 3 just be 3x. Okay, minus 5 multiplied by x just be minus 5x. Then minus 5 multiplied by 3, it's just going to give you a 15 there. Okay, is equals to 1. So it means you have log 9. Okay, what do we have in the brackets? We have x squared minus 2x there plus 1, 5 is equals to 1. Okay, so when we reach this point, we go back to our BAM there. Okay, go back to our BAM. Okay, so it means what do we have here? Base to the power answer is equals to what is in the middle. Okay, so what is in the middle is just this plus 5, I mean plus 15 is equals to base to the power answer. Okay, meaning 9 to the power 9, which is just, I mean 9 to the power 1, which is just 9. Okay, so let's solve this equation. You have 2x, you have plus 15, then you have minus 9 there is equals to 0. Okay, so x squared minus 2, and then there, what do we have? We have a plus 6. Is the plus 6 there? Okay, yeah, plus 6 is equals to 0. Okay. All right. Okay, so this equation now, can we solve it using factors? Okay, can we solve it using factors? Okay, I think no. Okay, show that whatever for all values of x. Okay. Okay, solve the equation that is equals to 1 for real values of x. Okay, so this equation here, I don't see it for factors. I don't know about you guys. Do we have factors for this equation there? What could be the factors? Kx. Okay, so I don't see factors there, meaning we have to use a complete the square method, or we have to use the GAN formula. Okay, so I don't know if this is really 9 there. Okay, you can find this not 9. Yes.
When we multiply -5 times 3, I don't know how we're getting positive 15. It should be -15.
Okay, oh, so I made a mistake here. Okay, no wonder. Okay, so this should be a negative there. Okay, thank you for that. So this should be a minus 15. Even there, it should be a minus 15. Okay. So minus 15. Then there it should still be minus. Okay, what will we get? Is it something that will make sense? Okay. So it means there will be minus 15, minus 15. Okay. So what is minus 15? Minus 9. Okay. It is minus 15 minus 9. The answer there will be minus 24. Okay. My answer there will be minus 24. Okay, and this minus 24,
24.
I can now see the factors, eh? You can see the factors, like I can, of this equation. We are still seeing blank. Okay, so the factors there, I'll just have a minus 6 and a positive 4. Okay, so I have x squared minus 6x plus 4x. Okay, minus 29 is equals to 0. Okay, so whenever the coefficient of x squared is 1, okay, you just combine your x's with those two factors. So this one factor will be x minus 6, then the other one will be x plus 4. Okay, this will be equals to 0, and it means my x values there will be equals to, one of them will be 6, and then or the other one will be minus 4. Okay, so these are logs. So whenever you're dealing with logs, you have to test your numbers. Okay, so this 6 will, I think, it will work properly, but will the minus 4 work? Okay, so you go back to your equation, then you try to input the minus 4. Okay, so if you put minus 4 there, okay, it means here you're going to have a minus 9. Okay, if you put a minus 4 there, you're going to have a minus 1, and you can't find the log of a negative number. Okay, so meaning this answer here, we're going to discard it. Okay, our only answer there will be that x is equals to what? 6. Okay, that will be our only answer there. X is equals to 6. Okay. What else? Okay, so we have, I can see differentiation now there. Okay, so let's solve that. Let's find the derivative of whatever we've been given there. Okay. Okay. Okay, so what method do we use to find that? Okay, so what do we have? We have x is equals to 2, which is raised to x to the power 2 plus 1. Okay, that's what we are differentiating. Okay. Okay, so meaning we are differentiating that. Okay, so what do we have? We have our our y is equals to 2, which is raised to power x squared plus 1. Okay, so how do we differentiate such an equation? Okay, so such an equation where we have a number, okay, a number is the one that is being raised to the power, okay, and it's not a variable, okay. It's different when you have x to the, I mean, when you have y, which is equals x to the power something, okay. So that one is very simple, but this one we have a number. So how do you differentiate that, okay? And we can see that this function is a composite function, okay? It's a composite function, meaning we are going to equate it to something, okay? So we're going to say this power there, okay? We are going to say the power is equals to v, okay? Then I have my x squared there plus 1. Okay, so if my power is equals to d there, okay, then my u is going to be equals to 2 to the power v, okay? So you can see where there was this expression there, I've put v there, okay? Then u is now equals to this expression, okay? I've not put the y, okay? So meaning from this guy here, I can find my du, okay, dx, okay. So what do I get when I find my du dx there, okay? So it means these two will come there, so this will just be 2x there. The derivative of a constant number there will be 0, okay? Then I come to this one, okay? It's 2 raised to power u, okay? Meaning here I'm finding du, okay? I'm finding du dv, okay? Finding du dv there, okay? So what am I going to find there? Okay, what am I going to actually find there? Okay, all right. Okay, so how do you differentiate such an equation? Okay, so to differentiate such an equation, you write the same expression, okay, the way it is, then you multiply by ln of the number that is raised to a power. Okay, so I don't know if that English was clear. So what I mean is that you write the same thing, okay? So you write 2 to the power v, okay? Okay, where is the rub? Okay, so you write 2 to the power v, then you say multiply by, okay? Then you say in the number that had the power. So the number that had the power there is just 2, okay? So this is the du dv here. That's how you find a number raised to power something. You write the same number, okay, as I did there. Then you say multiplied by ln whatever number here that was raised to a power. Okay, so ln 2. So it means my derivative there is that, okay? So now I have my derivative of dv dx, okay? And then here I have du dx, okay? But my aim is to find dy dx, okay? So how do I find now my how do I find my my dy dx? Okay, so to find my dy dx, I'm just going to multiply the two derivatives that I have, okay? I'm going to multiply the two derivatives that I have. It means I have, I'll say dy dx, okay, is equals to my du, okay, dx multiplied by, okay, my du dx multiply, I mean, this is dv, not dv, not du. Okay, my dv dx multiplied by my du dv. Okay, so here I have du dv there. Okay, so I multiply that to get my dy dx. What is my dv dx? Okay, dv dx, it's here, which is just 2x there. Then I multiply with my du dv, which is this. Okay, so it will be 2 to the power 2 multiplied by ln of 2. Okay, then I substitute back my v there. Okay, I substitute back my v there. Okay, what is my v? My v is simply whatever I have there, x squared plus 1. Okay, so meaning I have this expression here, 2x, okay, multiplied by 2, okay, to the power x squared plus 1, then I multiply this again by ln 2. Okay, so whatever we are getting here, that's the derivative, because you can't simplify this one further. Okay, so that's our derivative there. I don't know if we have any question there. Okay, so no question. I'll move to the next question.
Yes, sir.
You have a question?
Hello?
You have a
Yes,
question?
sir.
Yes, you can ask.
Yes. Is it okay if you can also help us in terms of where they had to put a number, which is 2, what if there was a variable? What are we supposed to do? How are we supposed to handle it?
Okay, so you are saying if here there was a variable here.
Yes, sir.
Okay, so that
Where
one
there
is the actual differentiation that you know. Okay, so y is equals to a variable here which can be x to the power 3. Okay, so how do you differentiate that? You just drop this one, the power, okay, then you reduce the power by a -1. So you say 3 minus 1 there, okay, meaning you're just going to have 3x squared. Okay, so when there's a variable raised to a power, it's not that difficult. You just use the same principle for differentiation. But when you have a number being raised to a variable like that, okay, that's where the problem comes in. So how do you differentiate this? We said you write the same thing, okay, then you multiply it by ln to the power the number that was raised to a power there, which is just 2 in this case. You've gotten it?
Yes, sir. Thank you.
Okay, that's good. So let's move. Let's move. Okay, so there we have evaluate the indefinite integral. Okay, so whoever sent this question, I don't know. So I'm not seeing the numbers that are there. Okay, but I'm seeing we have a cos 2x, cos 5x there. Okay, I'm seeing something like that. So I'll just tell you how to integrate this, but I don't know the values there, so I can't replace them into the equation. Okay, so there to solve this, they usually use the method for what method? Okay, they use differentiation by parts. Okay, they use differentiation by parts, but I have another way that is simpler than the differentiation by parts. Okay, because that one will take time for you to actually find the answer. Okay, so I'm going to use the one for the formula. Okay, so make sure you pay attention and you keep the formula. So when you just see such a question in the exam, just use the formula that I'm going to give. It's very simple and it's very direct to the point. Okay, so don't trouble yourself. Okay, so let me give you the formula. Okay, so whenever you are differentiating two functions, okay, whenever you're differentiating an equation of two functions that have cos and sine, okay, so in that case, what do we have? We have the integral of cos, this is cos 2x, okay, then we add the sine 5x there, okay, then they are saying we differentiate, we integrate this in relation to dx there, okay, yeah, that's the correct question. So how do you integrate such an equation? Okay, so I have a formula that can make your life very easy when you're given such an equation. Okay, so we are going to say that, okay, because you can see that the numbers that we have there, they are different, okay, and the trigonometric ratios that we have there, they are different. There are of sine, there are of course, and then there are of sine. Okay, so to differentiate this, okay, okay, you say that sine, okay, you say that sine nx, okay, multiplied by cos nx, okay, cos nx should be equals to, okay, the one has to be m, okay, so this one should be m. So sine mx, where this m can be any number, it can be 2, like in this case it is 5, the m there on the side, in this case it is 5, okay. So sine mx multiplied by cos nx, this n there is just these 2 there, okay. When you differentiate this, what do you get? You get half, okay. You get half is equals to sine, okay, sine, in the brackets there you say m minus n, okay, x, and then you say plus, I don't have space here, I'm going to write it down. You say plus sine m plus n, then you have your x outside there. Okay, so this here is the expression for your for expressing such an equation there, so that you can simply integrate it. Okay, so here what do we have? Okay, we have take note that our m there is just 5 from this given equation, and our n there is just what? 2. Okay, so from our given equation, which is cos 2x there, okay, then sine 5x there, okay, we're going to say this guy here is equals to, we're going to put half, okay, then in the square brackets, what are we going to put? We're going to say sine, okay, we're going to say sine m minus n, okay. So what is our m? It's just 5. What is our n? It's just 2. So 5 minus 2, it means we're going to get what are we going to get? We are going to get 3x, like that, okay. Then we are going to say plus, okay, sine this m plus 1, okay, sine that m plus n, not 1, I mean. So what is our m? 5. What is our n? 2. So 5 plus 2 is just going to give us sine, okay, that's going to give us sine 7x there. Okay, so once we get we know that this guy there is equals to that guy, okay. This guy here is simply integrated. Why? Because I have a sign and I have a sign there, okay. So I can simply integrate them, but there I had the cos, on the other side I had a sign, so it means I'll have to use differentiation by parts, which is a very confusing method, okay. So you should be using these guys, okay. So this guy here, we've said that it's the same as that guy, okay. So now we get this guy and integrate it, okay. So we are going to say the integral of half, okay. We're going to say the integral of half. In fact, this half here can even go outside there, okay. The integral of half sine 3x, okay, plus sine 7x there. Okay, so we have something like that. Then this half, we can take it outside there because it's a constant, meaning I have half, then the derivative of these guys there. Okay, sine 3x plus sine 7x there. Okay, so with respect to dx here, that's how I'm integrating this. So it's very easy to integrate a sign, okay? So how do you integrate a sign there? Okay, so the integration of the sign always gives us what? Cos. Okay, the integration of the sign always gives us cos. Okay, so what are we going to get? Okay, so if you integrate a sign, it means you are going to get a negative cos. Okay, so I hope you are following me. If you integrate a sign, you're going to get a negative cos. Okay. Okay, so if I integrate this guy here, how do I integrate this? Okay, how do I integrate this? I'll say half there outside, okay? Then I have square brackets. How do I integrate this guy? Okay, I say 1 over the number that is there, which is just 3, okay? And we said this should be negative. Then I said cos C. Then you write the same thing, okay? You write the same thing there as 3x there, okay? Then you say plus, what do you get when you integrate this sine 7 x, okay? So we said 1 over whatever number is there, which is 7, okay? We say minus, then this will be cos 7x there, okay? So this is what we have. Then we say close brackets there, okay? So we can multiply by the half. It means there, what are we going to have? We have minus 1 over 6 cos 3x, okay? Then plus, what do we have there if we multiply by half? We have 1 over 14, okay? This is minus there. Then cos 7, cos 7x there. Okay, so this, guys, is actually our integral. Okay, so minus 1 over 6 cos 3x, okay? Then minus 1 over 14 cos 7x, okay? So plus a constant c that we don't know. So this here is our integral, okay? So that's how you integrate that question using this formula method. I don't want to use the partial fraction ones. Okay, so let's continue. Okay, so where are the questions? Okay, so we've solved this. We move to the next. Okay, so let's solve these questions. Okay, so how do we solve those questions now? All right. Okay. Okay, so the first question there, they're saying differentiate, okay, or find the dy dx of x squared minus xy plus y squared is equals to 3. Okay, so we can see that in that equation we have two variables. Okay, we have two variables. We have x and we have y. Okay, we have x and we have y. So whenever you have two variables in an equation, then it means you are going to use the we are going to use the explicit differentiation. Okay, so how does that work? So let's go there. So we have that guy there, then we want to find the dy dx. Okay, so you go on your board, then you say I've been given x squared, okay, minus xy plus y squared, okay, is equals to 3. Okay, so how do you find the dy dx here? Okay, so for the variables that have x, you're going to find the dy dx the usual way that you find. Okay, you're just going to drop this power in front, then you reduce it by 1. Okay, then for y, you're going to do the same thing that you're doing on x, but to that number that you find, you're going to add dy dx. Okay, so I don't know if it's making sense, but it will make sense when I write it down. Okay, so meaning this side, okay, and that side, we're just going to find the dy dx. Okay, so what is the dy dx of this? The dy dx of this, it means we're differentiating this. We're just dropping the power of 2. Okay, so it will be 2x. Okay, it will be 2x there. Then I'll say minus. Okay, you can even put it in brackets. I'll say minus. Okay, then here I have two equations. I have x and y, meaning here on this guy here, I'm going to use the product rule. Okay, I'm going to use the product rule. And I hope you know what the product rule states. Okay, so the product rule states that I differentiate this one, then I keep this one constant. Okay, so the derivative of this one multiplied by this as it is plus the derivative of that one, then I maintain that one as it is. Okay, so that's what I'm going to do there. Okay, so I'm going to say minus, then in the brackets, I'm going to say, what is the derivative of x? Okay, so the derivative of x is just 1. Okay, then I multiply it by the other function as it is. Okay, the other function is y. Okay, then after that, I'm going to say plus, what is the derivative of y? Okay, so we said when you are differentiating y, we are using the same method that we are using on x, but to that answer, we are going to add dy dx. Okay, so meaning here the derivative of y is just 1 again. Okay, then this one, I'm multiplying it by the function that is remaining as it is. Okay, as it is there. Then to this product that you are going to get, you're going to add dy dx. Okay, why? Because you are differentiating y here and not x. Okay, you put it in brackets, then you say plus. Okay, so this one here is y squared. Okay, why? How do you differentiate y squared? We drop the power there. Okay, we drop the power to be 2y. Okay, then since we are differentiating y, we add dy dx. Okay, I hope you are getting it. Then is equals to, what is the derivative of a constant, guys? Okay, what is the derivative of 3? The derivative of 3 is just 0. Okay, then after that, you can put like terms together. Okay, after that, you can put like terms together. Okay. 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 So here now we put like terms together. Okay, meaning we are going to have 2x there. Okay, minus whatever is in the bracket 1 by y, it's just y, plus, okay, 1 multiplied by whatever we have there is just x dy dx. Okay, then plus, what do we have there? We just have 2y dy dx. Okay, and this will be equals to 0. Okay, so here now, what are we going to do? We are going to put like terms together. Okay, so the 2x there will be there. Then I'll say minus y. Okay, then this guy here will get a minus x dy dx. Okay, then plus 2x dy dx there. Okay, is equals to 0 there. Okay, so here we are going to leave all these guys with the dy dx's. We are going to leave them this side. Okay, so I'm going to remain with the 2 dy dx this side. Okay, then minus x dy dx. Then on the other side, what am I going to have? Okay, this y will go that side, this 2x will go that side. So I'm going to have the y minus 2x. Okay, then from here now, I'm going to factorize the dy dx. Okay, so dy dx. Okay, then I have 2y there minus x. Okay, is equals to y minus 2x there. Okay, so I divide by 2 minus x on both sides. It means my dy dx there will be equals to y minus 2x, okay, over 2y minus x. Okay.
Oh, sorry, sir. I'm a bit behind. How did you get y minus 2x again?
Y minus 2x. Okay. So you can see here that I have a y dy dx there minus x dy dx. So I factorized the dy dx because it's appearing here and it's also appearing there. Okay, so I factorize it. Then it means that here I'll just remain with the y. I mean 2y, then minus x. That's why it's coming from this guy here. Okay, so you divide
Okay.
and then
I was referring to the one on the other end.
Come again.
I was talking about the one where it's y minus 2x. That's the one.
This one here.
Yeah,
Okay.
yes, that one.
Okay, so here we had this expression here. Okay, so I said whatever dy dx here will remain on the left side. Okay, this was what remained. Then this guy is here, they moved to the other side like that. You can see that this minus y became a positive y, then the positive 2 became a minus 2 there.
All right, thank you, sir.
So what's the other question there? Okay. Okay. My hands are tired, guys, of writing. Okay, so let's solve these ones, then we can rest and then we later. Okay. All right, so now use integration by parts to evaluate the following integral. Okay, so here I'm going to use now the integration by parts. But that other one, I have showed you another method. Okay, so you have two advantages now. So I'm going to integrate this one using integration by parts, and then in the answer that I'm going to get, I'm going to import the e and the 1. Okay, because here we are finding the actual value. We're not just integrating. Okay, we're not just integrating. Okay, so integration by parts has a formula. Okay, integration by parts has a formula. Okay, so integration by parts has this formula. Okay, so integration by parts is equals to the integral of u, okay, dv dx. Okay, you have to know this formula, guys, not two ways about it. Okay, the integral of u dv dx, okay, is equals to uv minus, okay, the integral of v du dx, okay, du dx, like that. Okay, so this is the formula for differentiation by parts. Even that other question there, the one I used the formula, you can still use this formula for differentiation by parts. Okay, so where are you going to get the u? Where are you going to get the v? Where are you going to get the du? Where are you going to get the dv? Okay, so what question have we been given there? We're told to evaluate the integral of this e1 there. Then you have 4 x to the power 3 in x. Okay, then dx there. Okay, so we are going to choose our u and our dv dx from this function. Okay, we are going to choose our u, which is this u there. Okay, and our dv dx, which is that dv dx from this function here. Okay, so how do you choose that? You always choose the dv dx to be that number that you can easily integrate. Okay, so you cannot easily integrate ln. Okay, you cannot easily integrate ln, so it means the dv dx is 4x to the power 3. Okay, so you say dv dx is equals to 4x cubed. Okay, then the u, you always choose the one that is difficult to integrate, which is the ln x. Okay, but it's simple to differentiate. Okay, so is equals to ln x. Okay, so from the du dx, you can actually go backwards and find your v. Okay, from the dv dx, you can integrate that expression to go back and you find your e. I mean your v. Okay, so it means my v here will be equals to, okay, let me integrate this. Okay, how do I integrate? It means I increase the power there by 1, and then I'm going to differentiate. I'm going to divide by the same thing. Okay, so I have 4x to the power 3. I'm going to increase it by 1. Okay, then I divide that expression by the new power, which is x, 3 plus 1. Okay, so it means I have 4 there, and then there I have x to the power 4. Then there are 4 divided by 4, they will just cancel. Okay, So meaning here, what I'll have is just x to the power 4. Just have x to the power 4 here as my v. Then here I have my u. Okay, so from my u, I'm going to use my u to find my du dx. Okay, so what will be my du dx here? Okay, du dx will be equals to, what is the derivative of ln? Okay, we all know that the derivative of ln is just 1 over x. Okay, 1 over x. Then after you find that now, you can simply go back and input them in the formula. Okay, you can simply go back and input them in the formula that we wrote. Okay, so let's do that. So what is the formula that we wrote per first paja? We said, okay, we said that if you are integrating something between limits a and b, okay, and that thing is u, okay, you multiply the u by dv dx, okay, is equals to, on the other side, it will give you u v minus the integral of du, I mean v du dx like that. Okay, then with respect to dx like that. So we are going to replace what our u we have, okay, what u we have here, the u we're going to replace there, the dv dx we're going to replace there, okay, the v we're going to replace there, the u, and then the du dx. Okay, so what is our u? Okay, what is our u? Our u is ln x. Okay, our u is ln x. So I'm going to say limits starting from e there. Okay, we have ish. What is happening to my pencil? Okay, so we have my e there, I have my 1. Okay, what is my u? My u is ln x, guys. Okay, ln x, then I'm multiplying it by my dv dx. Okay, what is my dv dx? My dv dx is 4x to the power 3. Okay, so I would say 4x to the power 3. Okay, then this guy with respect to x there should be equals to, what do I have here? I have my u, okay, my u is ln x, okay, multiplied by my v. Where is my v? My v, okay, my v is x to the power 4. So x to the power 4, okay, minus the integral of v. What is my v? You go back and check. Your v is still, yes, x to the power 4.
dx x to the power 4.
I come again. I can't get you.
Isn't our dv dx x to the power 4?
Our dv dx, no, our dv dx is this one, 4x to the power 3. This here, this is our dv dx. Then this x to the power 4 is our v. Remember, we integrated this dv dx to find the v there. You've seen it?
Yes, I have. Okay, thank you.
Okay, so let's continue. So I mean, I will replace there with v, which is x to the power 4. Then what is my du dx? Okay, so my du dx is 1 over x there. So I'm going to put 1 over x there. 1 over x there. X. Okay, so after that now, okay, after that now, it means here I'll still have the same thing, okay? I can just change them positions, like I put x multiplied by ln x, okay, minus, then what will I get when I integrate these guys here? What will I get when I integrate these guys, okay? So you can see that I have x to the power 4 being divided by x, so it means I'll just have x to the power 3 there. With respect to dx, okay, is equals to, still the same thing there, okay, plus ln x minus, okay, what is the integration of x to the power 3? Okay, we increase the power by 1, then we divide by the new power, meaning I have x to the power 4 being divided by 4 there. Okay, so that will be my my equation there. Okay, that would be my equation there. Okay, so from there now, I can say in this equation, I'm going to input the limits e and 1. Okay, don't forget your limits there. Don't forget your limits there. Okay, because we are evaluating, then I'll say in this equation, I can see x to the power 4, x to the power 4. So I'm going to factorize it, meaning I have x to the power 4, and then inside I have in x minus, okay, then here I have just have 1 over 4. Okay, then I'm inputting e and 1 there. Okay, meaning is equals to, I'm going to say where there's x now, I'm going to put e to the power 4, okay, then 4 like that, then minus 1 over 4, okay, then we say minus, then we now input 1 wherever there's x, so the power 4, then 1, okay, minus 1 over 4. Okay, so how do you simplify that now? We know that ln 1 is just 0 there. Okay, so meaning here we have e to the power 4 ln 4 minus 1 over 4 minus, okay, what do we have here? We know that ln 1 there is 0, okay? Then 0 minus 1 over 4, we're still getting 1 over 4 there. Okay, 1 over 4. Okay, continuing the answer, we're going to get e to the power 4. In brackets, we have ln 4 minus 1 over 4. Okay, then outside we have plus 1 over 4. Okay, so this here will simply be our answer. Okay, will simply be our answer. Is it okay? Okay. Okay.
I've fallen behind on the substitutions and how to substitute.
Okay. I even made a mistake here, guys. You didn't correct me. Okay, so here, oh, okay, here on the x, I put 4 here instead of e. You didn't correct me. Okay, so there was x there, supposed to be e. Supposed to be e there. Okay, I'll go back to the substitution, but here, supposed to write e, then even there, supposed to write e. Okay, and we know that ln e is just 1. Okay, meaning we can simplify this further. It means inside there, we're just going to have 1. Okay, plus 1 over 4. Okay, what is 1 minus 1 over 4? 1 minus 1 over 4 is just 3 over 4. E to the power 4 plus 1 over 4, like that. Okay, so this is the answer there. Then where you are saying, where are you lost on the substitutions? Hello, the one who is asking a question.
Yes, like from the actual differentiation parts formula all the way to
this one here, the formula.
Yes.
Okay, so the only thing that you have to do for you to know the formula is you have to look at it, okay, memorize it, and then solve questions using it. Okay, that's the only way you have it stick into your head. Okay, and how do you substitute? Make sure that where there's u, you put u. Where there's v, you put v. Where there's v again, you put v. And where there's du dx, okay, you put du dx. Okay, how do you find the v? How do you find the u? How do you find the du dx? Okay, we said when you are given such an equation there, okay, you have to select your u as something that can easily be differentiated. Okay, so between this guy and this guy, the one that can easily be differentiated is this guy. Okay, because we know the differentiation of ln x is just 1 over x. Okay, no wonder we chose it as u. Then how do you choose your dv dx there? Okay, how do you choose your dv dx? You choose something that can be easily integrated. Okay, so this expression here can be easily integrated, and then that's why you chose it. Okay, then from the DUD E, we are going backwards now. We are going back to the V there. Okay, so how do you do that? You integrate this, and we found that. Okay, so we have our V there, we have our DUD X there. Okay, we have our U there, and we have our dVdx. Then you just get those and put them into that formula. That's all. Okay. Yeah. Okay, so let's solve these two questions, then we can call it a day. Okay, so write down the expression log B12 minus 1/2 log B9 as a simple logarithmic function. Okay, so that one is not difficult. Okay, let me go to the pen paper. Okay. So that one we have log 212, okay, minus 1/2 log B9. Okay, so the first step here is to raise the power. Okay, I can see that power, okay, I can see that this half can be raised to become the power of 9. Okay, so it will be minus log B there 9 to the power half. Okay, and we said anything raised to the power half is the same as the a square root. Okay, so it means this 9 to the power 1/2 is the same as square root of what? Square root of 9. Okay, and what is the square root of 9? We know that the square root of 9 is just simply 3. Okay, meaning this one will be log B3. Okay, log B3. Then after that, now you can express it as a single log. Okay, whenever you are subtracting, it means you are dividing whatever numbers are here and there. Okay, so is equals to, we're going to get a log B there and a 4 there. Okay. So we have expressed it as a one logarithmic function. Okay, so simple and straightforward. Then let's solve the last question. Okay, so we have the identities now there. Okay, they are saying prove this identity. Okay, so 1 plus cos x over sine x is equals to 2 cosec x minus sine x over 1 plus cos x. Okay, so how do you prove this? How do you prove this expression? Okay, so you always choose to prove the side that looks more complicated. Okay, so between the left there and the right looks more complicated. So we're going to prove that the right hand side there is equal to the left hand side. Okay. Okay, so meaning I have 1 plus, okay, I have 1 plus cos x over sine x, which should be equals to 2 cosec, okay, 2 cosec x minus sine x over 1 plus cos x there. Okay, so we said this guy here looks more complicated, so it's the one that we're going to prove. Okay, so we're going to say that, okay, we're going to say that our 2 cosec x there minus sine x over 1 plus cos x is equals to the left hand side. Okay, so how do we prove that those two are the same? Okay, so we prove by multiplying, okay, by multiplying the second expression here by its conjugate. Okay, so it means we have 2, okay, we have 2 cosec x minus, okay, then we have sine x there over 1 plus cos x, okay, So we are going to multiply this expression here by its conjugate. Okay. So the conjugate there, we're just going to put a minus where there's a plus there. The same expression, but with a minus there. So cos x is equals to the left-hand side. Okay, so one thing I have to state about proving identity is that they don't have one way of solving it. Okay, so you can solve them in any way that will give you the answer. Okay, there's no general way how you can use. And another thing is that when you've never seen a function, you've never seen an identity before, or you've never proved it before, then it's going to be a bit tricky for you to actually find the answer, because it just looks impossible. Okay, just looks impossible, and each method has different ways. Okay, so make sure you solve as many identities as possible, so that if they repeat one of those, you can simply solve it. Okay, so from there, what do I have? Okay, from there, what do I have? It means I have my 2 cosec x there, okay, minus, then on top there, I'm multiplying this sine x by 1 minus cos x there. Okay, so meaning, what do I have on top? I have a sine x there minus sine x cos x there. Okay, over, what do I have down? Down there, I'm multiplying conjugates of each other. Okay, we said, how do you multiply conjugates? Just simply say 1 squared, then we say minus the other one there squared. Okay, so meaning down here, what are we going to have? We're going to have 1 squared minus cos squared. Okay, and we can see that this is the identity for what? This is the identity for sine. Okay, so 1 minus cos squared x is the same as sine squared x. Okay, and this should be equals to my left-hand side there. Okay, so now let's simplify whatever we have. Okay, let's simplify whatever we have. Okay, so we are going to divide, okay, that sign into each of those numbers. Okay, so the cos x remains intact, but this sign here will go into the sign. This sign, the squared x, will go into the sine x, and it also go into the sine x cos x. Okay, so it means okay, so here you have brackets. This should be in brackets. Okay, so this sine x will go with that. It means you have sine x, okay, over sine squared x, okay. Then again, this cosine will go with that, okay. Negative multiplied by negative, which means I have a plus there. Then I have sine x cos x there over sine x squared there is equals to right hand side, okay. So from there, what can we see? Okay, we can see that here the 2 cos x there remains the same. Don't touch it, minus, and then here sine x over sine squared x. It means there the sine x will go, and then there will remain with 1 sine x. Okay, and we know that 1 over sine x is what, guys? Okay, 1 over sine x is what? Is just cosec. Okay, that's the identity for cosec. So meaning whatever is here will just be a cosec there. Just be a cosec. Okay, then cosec, this is cosec x, then plus, then what do we have here? We're going to cancel the sign and cancel 1 sign there, meaning we are going to remain with cos over sine there. Okay, then this is equals to right hand side. Okay, so there you have 2 cosec minus cosec, meaning we just have cosec there. Okay, cosec x, then plus, what do we have there? Okay, what do we have there? We have a cos over sine there. Okay, is equals to right hand side. Then this cosec, we know that we can write it as 1 over sine x plus cos x over sine x. Okay, so is equals to right hand side. Then here now you can say that sine there is a common denominator. Then on top you're just going to have 1 plus cos x there, which is equals to the right hand side. We can see that this indeed is the expression that was on the left hand side. Why am I writing right? Left hand side. Okay, then you say hence proved. Okay, so that's how you solve that question. Okay, so I'll upload this video on Drive. So in case you didn't understand this, just simply watch the video again. And you can also view the solutions, because I solved these questions. They were in the exam for 1100 last year. Yeah, so you can also view the solutions there just to have a deeper understanding. Okay, so thank you very much. We'll continue the revision another time.